Hello there, welcome to a new session. In this session, we are going to talk about the polymorphism. Polymorphism is one of the most important concepts of object-oriented programming, and polymorphism defines as the existence of a process in many forms. Let me write it here. Polymorphism defines as existence of a process in many forms or multiple forms, many forms. Now you will definitely have a problem reading this definition, that what does it mean and how to implement this in Solidity. So let me break down this definition, that what does it mean, and the only keyword that you will have problem with is process. Now you will definitely understand that existence of process in many forms, but what is the meaning of process in context to Solidity? So process, let me break down this process keyword. Process means something is going on, or a thing or work is going on. So if work is going on, or for let that work going on, you have given some set of instructions. So process means set of instructions. Let me give it set of instructions. And in context to programming, set of instructions are functions. So I hope this thing is clear now. Functions. Existence of functions. Let's remove this a. Existence of functions in many forms. Now it is clear, I think. Existence of a function or existence of functions in many forms, in different forms. If I will give you the example of polymorphism in Solidity, then let's assume that you are having a program in which you have created a contract, and a contract, in that contract multiple add functions are there. One add function is responsible for adding two numbers, another add function is responsible for adding three numbers, and another add function is responsible for adding four numbers. So like that, a function is having multiple forms. F add function, the name of the function is same, but that function is created multiple times. Name of that function is same, but the number of parameters are different. So in this example, a function add is existing in many forms, or it is existing in a single contract, or within a contract. If a function exists multiple times, so that is considered as a polymorphism. So actually in Solidity, and you will definitely have a problem that how to implement it in Solidity. So let me tell you that there are two types of polymorphism in Solidity, or basically there are two types of polymorphism. One is of compile time, and another is of type runtime. Runtime polymorphism. Sorry, yeah, runtime polymorphism, compile time polymorphism. Now, what does this mean? Compile time polymorphism or runtime polymorphism? So the things which would be figured out on compile time, or functions which can be figured out that which function would be executed in compile time, then that type of polymorphism would be considered as compile time polymorphism. And a function runtime polymorphism can be achieved with different things, and compile time polymorphism can be achieved with different thing. I will tell you that also. When which function would be executed would be decided on runtime, that thing is considered as runtime polymorphism. So compile time polymorphism can be achieved through function overloading. Function overloading. If you are having some background from C, C++ or Java like programming languages, then you will definitely know these things like function overloading, function overriding. So I hope it is clear. I will tell you this, don't worry about it. And if we talk about the runtime polymorphism, then runtime polymorphism can be achieved and can only be achieved through function overriding. Function overriding. Function overriding. So these are the two things through which you can achieve the compile time polymorphism and runtime polymorphism. Now let's see what is function overloading. Function overloading means whatever I have told you previously, or whatever I have told you in the last 4 to 5 minutes, I think. So let me tell you the proper example of that, or let's create a proper example for function overloading. Function overloading means creating a same name function creating a same name function but different parameters or different number of parameters. Number of parameters or different parameters. Both of these things would be okay. Different parameters, sorry, not parents, parameters. Different type of parameters. Then it is function overloading. FO. So function overloading is this, and within a contract, within a contract, within a contract, creating a same name function but different number of parameters or different type of parameters, then that is considered as function overloading. And through function overloading, you can achieve the compile time polymorphism. So let me create example for that. So let's go to your remix IDE and let's create a new file, compile time polymorphism dot sol. Okay, so here we are. Let me give the comment as soon as fastly. Spdx hence identify what is happening, identifier, and GPL 3.2 general public license, and pragma solidity uh, greater than 5 point, sorry, it's point 5.0 and less than equal to 0 0.8 sorry 8.0. Okay, now let me create a contract calculator. Okay, and in this calculator contract I will be creating several functions. Let's say function add, and all the function would have same name but the parameters are different, uint a, uint b, and this function is responsible this separate function is responsible for adding two numbers or two unsigned integers. So let me do that, or it will return the sum of two integers. So let me give this function as public pure and it returns unsigned integer. Okay, now let me create another function which would be responsible for returning the sum of three different variables or three different unsigned integers. So see this. If you will declare or if you will define the same type of function, then it is not allowed. But it should have different number of parameters or different type of parameters. It is okay if it is having different number of parameters or different type of parameters. But if you are giving or if you are creating the exact replica of it, then it is not allowed. So let's give the different number of parameters. So I uint c. So it is okay now. Now let me give plus c. So this is considered okay. Sorry, I have given underscore. Okay, yeah, now it is okay. So this can be considered as the compile time polymorphism, because if I will call add with by passing two arguments, then this function would be called. And if I will call add function by passing three arguments, then this function would be called. Means a single process is having multiple forms, and which form I get executed should depends upon the input. Mean whatever input that I will give, that form would be executed of that process. So let me deploy this program. Let's deploy it, and okay, let's give some data. Okay, let me give 5 comma 4. Let's give add, so it is giving 9 to me. And if I will give 5 comma 6, then it will give 16. It is not returning, I think. It is having some errors, that invalid big number string it say. Okay, sorry, I have given floating point numbers. Sorry, floating point numbers are not allowed. Okay, I have given dot on both the day. Okay, okay, now it is giving 16, so it is completely okay, and that's how you can create the compile time polymorphism example. So achieving compile time polymorphism is quite easy, and it is easy to understand. Now let's talk about the runtime polymorphism. And whenever you see this, when you want to call the add function with three parameters, then you will choose this function. You cannot say I will call this function, because this function is not having three different parameters. See this, it will give you the errors. So that's why if you want to add three numbers, then you will definitely call this function which is having three parameters. So it is decided on the compile time itself that which function would execute it when you are giving three parameters, and which function would execute it when you are giving two parameters. So that's why this type of polymorphism is considered as compile time polymorphism. Now let's talk about the runtime polymorphism. What is runtime polymorphism? So runtime polymorphism can only be achieved through function overriding time. Or let's talk about function overriding this time. Function overriding. If we talk about function overriding, then function overriding is creating the replica of a function in base class to the derived class. Like for example, you are having an animal class. In animal class, you are having a make sound function. Make sound function, it is not having any parameters, and it is having a return type as a string. It returns string type of data. So this is an animal class, and then you have created another class which is a dog class, and dog class is inheriting this animal class because dog is also an animal. So it is inheriting the animal class, and this dog class is also creating the same function as animal class. So make sound, and it is not having any parameter. It returns string type of data, returns string. So this is an example of function overriding, means creating the replica of a function which is inside the base class into the derived class. So that's what the exact meaning of function overriding. I hope this thing is clear. If you want, then you can note it down. I'm not writing it here because my writing is not good, so please write it by yourself. And one thing you should know that uh, base class object base class object or pointer is capable of storing the derived class object derived class object, but vice versa is not possible. Isn't possible. So vice versa is not possible. Like if you want to create, if you have created an object of derived class, and if you want to assign the object of base class to that derived class object, then it is not possible. So mark this thing and note it down if you want. This is very important thing. And this function overriding plays around this thing. So let's see what is function overriding, and let's create an example of function overriding. And function overriding, and through function overriding, how can we achieve the runtime polymorphism, we are going to see. Let's see. So as add function is there, so let me remove it and let me create the class animal. Sorry, I just forgot that it is having contract. So contract animal, and okay, here in this contract, let's create a function make sound, and it is returning, or sorry, it should be of pure public pure. And I will tell you one more thing. Let me create this program first, or let me create this function, sorry. So it returns string type of data which is of memory. Okay. And okay, that's enough. And let's return a string type of data from here. String str animal makes sound, and return str. Okay, so this is our animal class that we have created. Now I want to create a dog class which would be inheriting the animal, because dog is also an animal, cat is also an animal. So I will be creating two different classes, dog and cat. So let's create dog class dog, which is inheriting animal class. So I hope it is clear that how to inherit any class. With the help of is keyword, you can inherit any class that you want. Sorry, I just forgot that we need to use contract here. So contract dog is enemy. Okay. Now in this contract, I will be creating a make sound function which is of pure type, which returns string type of data. Okay, so how the dog makes sound, do you know? Dog makes sound like, let's say, dog barks. So dog barks. Okay, return str. Now it will definitely give you the error, because if you want to uh, create the same replica of the function that you have created in the base class, and you want to create the same function in your derived class, so you will have to give a keyword. So you will have to make your function as virtual. So if we will be using virtual keyword here, then the problem will be gone. So here also one problem is there, and here also you will have to use one keyword. I will tell you that, but first let me conclude it. So if you want to, or if in the base class, if you want that that any function would be overridden, that is what the meaning of overriding. Like if you are creating the same name function in the base class, or sorry, if you are creating the same name function of base class in the derived class, then that thing is considered as function overriding. So if you want that any other class would override your function, or override the function that you have created in the base class, then you will have to create that function with virtual keyword. That's what the theory. Please note this theory down, because it is very important in Solidity programming language. Now, if you are a derived class creator, and if you want to override any function, or so you will have to write a keyword override. Override keyword is need to be written with the definition of the keyword. So override. Sorry, it is I just forgot. Okay, override. So now the error has gone. Like this, you can override any number of functions from the base class that you want. Now let's create. I hope this thing is clear, and I hope how to use the override and virtual functions. So let's create another contract. Contract cat. Cat is animal. Just pause this video down here and try to create the cat class by yourself, cat contract by yourself, sorry. So cat contract by yourself. And even I will suggest you or recommend you to create this complete program by yourself without watching my solution. Now function make sound public pure override returns string type of data, which is of memory type. Okay. Okay. Now let me create a string type of variable cat sounds, or let's give the sound itself meow meow, because cats sound like meow meow. Okay, now let's return this sound. Now the main thing comes into the picture. You have created base class and derived class. Now you will have to create a class. Let me create a another contract. Sorry if I am saying the class, so please replace that class with contracts, because whatever I have learned in Java and C++ and Python, so I always whenever I am creating this type of contract, so I always say class. Sorry for that. Contract, let's say main contract. In this main contract, we will be creating the object of animal class, object of animal contract, and that animal contract object would be having the object of its derived classes. See this. So let's see what happens. So animal A is equal to, or animal is equal to new animal, and let's give it as string string memory str1 is equal to animal dot make sound. Let's see. So I think string, oh, sorry, it should not be it should be public. Okay, as you are creating the state variable, so it should not have memory keyword. I already told you everything about it. Now let's create another object animal2. Animal2 is equal to new, and this time we will be using the dog class object for instantiating this animal2 object, because as I have already told you that derived class objects are capable, or sorry, base class objects are capable of storing the object of derived class. So that's what we are doing. Contract, sorry. So that's what we are doing here. Let's give the object of dog class to animal class. So it is allowed. See this, we are not getting any type of error. Now let's see string public str2 is equal to animal2 dot make sound. Now let's create another object animal3 is equal to new cat. This time we are assigning the object of cat to animal3 object, and we will be using the make sound object, or sorry, make sound function of animal3 class to get the sound that cat has. Now let me deploy this program and let's see what happens. Just try to predict the output, please. And if you are from the C++ and Java background, then you will definitely know the output. But if you are not from the Java or C++ background, then please try to predict it. So sorry, I think uh, I have deployed the wrong contract. So remember this thing. This is very important thing. If you are creating multiple contracts in the same file, you will have to choose whichever contract that you want to execute. So I want to execute main contract. So deploy. It has been deployed, and let's see the instance of that deployed contract. So here we are getting three different strings. So let's see what we have got in str1. Try to predict that what we will get in str1 string animal.make sound. Here we have assigned the object of animal class to itself. So try to predict that what we will get. If you are having the instance of that same class, then that same class function would be executed. Means make sound function would be executed of animal class. So it will return animal makes sound. See this. It is giving, or it is returning animal makes sound. Now let's talk about the str2. What should str2 returns? Let's see. Now in animal2 object, let me separate it. In animal2 object, we were having the dog object, or animal2 object has been instantiated with docs object. So is it, or what would happen? Please try to predict. Now what happens is, as you have given the object of dog, or you have instantiated the animal2 object with dog class. So what happens is, make sound function would be searched in dog class. Please mark these words. Make sound function would be searched in dog class first. Then if that function is found, if make sound function is found, currently it is the make sound function. We are having the make sound function in dog class. So if the make sound function found in the dog class, then that function would be executed. Otherwise, if the make sound function is not found after searching in dog class, then the base class function would be executed. That's what the complete theory. Please note this theory down, and you don't need to do anything if you know this theory. So let's execute this. We will get dog barks, and if we will execute the str3, sorry, if we will access the value of str3, then it will give meow meow. See this, we are getting dog barks meow meow. So that's what the basic theory that we knows. Now let's remove the make sound function from this class. From dog class, I have removed the make sound function. Now let me deploy the program again. Oh, sorry, smart contract again. That is the same effect for the, sorry, I have deployed the wrong contract, animal contract. Let's deploy the main contract. Okay, so I have deployed the main contract. Let's see what it gives. So we are having str1, str2, and str3. So let's access str1 first. So we are getting animal makes some. Now let's access str3 now. It gives meow meow. Now please try to predict. I have removed the dog make sound function from dog class. Let's see what it gives. So it gives animal makes sound. Why it has given animal makes sound to us? Because in the dog class we are not having make sound function. So as we have instantiated the animal2 object with dog class, so it would search in dog class first, and if it is not found, then it will search in the class which, or in the class through which that object has been created, or basically it is the base class. So it will search in this animal class. So in animal class it would be searched, it has been searched, and animal makes sound has been written. Now let me tell you that how it is a runtime polymorphism. Basically when we have created all the make sound functions in all three class contracts, then what happened is the same function were executed, or the function of each class has been executed. But when I have removed the make sound function from dog class, then animal class function has been executed. So that's why it is searching on execution. It is not decided that which function would be executed. If that class has the function, then only that function would be executed. If that function is not, if that class is not having the function, then that function would not be executed, or the base class function would be executed. So there is randomness or uncertainty of execution of any function. So that's why, and that's what the reason that this type of polymorphism is considered as runtime polymorphism. So I hope this thing is clear, that why this type of polymorphism is considered as a runtime polymorphism. And please try to create this example by yourself without watching my solution. If you are having any problem, then you can definitely solve it or watch this. But please try to do this by yourself without watching it. So that's what I wanted to tell you with the help of this session, and I hope all the doubts of your is clear. So that's all about this session. Thank you very much.